Hi guys, it's Talha here. So today, what we learned at the university, uh, we learned some, in the first period, uh, what we learned was about functional English. So what we learned in that was about synonyms and antonyms. So I'm going to explain what are these two, what do they mean, and how are they similar, how they differ, that kind of stuff. And then after that period, in the second period, we learned some calculus. So there we learned about the formal not the informal. So prior to that we learned about informal definition of limits, but today we learn about formal definition formal definition of limits. And I'm also give you guys some I'm also going to give you guys some examples related to it, and it's pretty interesting as well. And in the last period, today we learned some topics in fundamentals of computers. And if we have time, we will discuss this third topic, but if we don't, we can only stick with the above two. So in the first lecture, what we learned was about synonyms and antonyms. So synonyms have are basically is a term used to describe, for example, you got have two words with the same meaning. So if you have two words, or if you have a word which is related or which has the same meaning to another word, that will be called its synonym. And antonym is when there's a word and another word is opposite toward the first word is. For example, to synonym, for example, if I say that beautiful is a word. So if I want to know uh, what kind of synonyms are there for this word, so the first thing which comes in my mind, that is pretty is also, when you use a word pretty in a sentence, that means you're actually saying that something is beautiful. You can also use pretty. You can use breathtaking. It's up to you whether you what kind of what choice of words you have for a sentence, for using them in a sentence. So you have breathtaking, you have many other words, you have many synonyms. You can have a lot of synonyms for a single word, but one property of synonym is, for example, you have beautiful. Beautiful is only used for this word beautiful itself, but pretty and breathtaking, these kind of the words that are synonyms, can also be used for a variety of other things, not only just for this particular word that I said. Then we have antonym. So what antonym is basically the opposite of the word. For example, if I say beautiful, if this is a word, so the first word that comes in my mind that is going to be the opposite of this one, there will be ugly. Ugly, ugly. You can say that's opposite, completely opposite of this word. So for beautiful we have ugly. For just, this just is not mere. Mere is something else. This is just, where it's derived out of the word justice. So you have just, you have if you want to find the antonym, you have got to write unjust or unfair. And if you want to find the synonym you for just, you can write fair. So this was synonyms and antonyms. So why do we use synonyms and antonyms? They are used to embellish or beautify your writing piece, because if you're going to use the same word again and again, it's not, it if you use the word synonyms and antonyms, it makes your writing piece stand out from others. So you will be more your writing piece will be more noticeable in comparison to other who have wrote the same thing. So this was about synonyms and antonyms. Now we are going to discuss the our second lecture, that was about calculus, and that was about formal definition of limits. So In the previous videos, I've discussed what are limits. The informal definition, where I've stated that if limit of x approaches to x naught, and you have f of x, so its limit is, for example, is going to be L. So as in the previous videos, I've stated that as x naught approaches to x, as x limit of x, as this domain x approaches to x naught, f of x approaches to L. That is the limit. That was the informal definition. Now what is the formal definition? In formal definition, we use the two terms that are delta, which is noted by this, I think, yeah, and the second term we use, that is epsilon, noted by E. So so what a formal definition of a limit is that, for example, let me just draw a graph. Okay, so there's a function, let's say there's a function limit of x approaches 2, and you have 4x x minus 2 divided by x minus 2. So this is a function which is not defined at 2, because if you'll put 2, you're actually going to get undefined, because anything divided by 0 is undefined. So this is your function. So what a formal definition of a limit says is, okay, so if you graph this function, so let's say that this is a graph of a function, this of a limit of a function. So what a formal definition says, if I write it mathematically, that if I write this expression as a formal definition of a limit, so I'll have to say that x minus delta, x minus x naught, which is the limit, absolute of x minus x naught should be greater than 0 and less than delta, and f of x minus the limit. So this was the x, which was a domain, and the x naught, which was the term it was approaching to. And then we write f of x minus L, which is f of x is your main function, and L is your limit. L is the output or the answer of the limit, which it outputs when you apply the limit. So you have f of x minus L should be less than epsilon. So what a formal definition of a limit says, that if a person tells you to, if a person asks you to find this delta, this delta, by the way, is the change, or is the distance between the point, or from the point at x that is undefined, and then you go to the left and you go to the right. And here also, for example, this function is undefined. For this function is undefined at exactly this point, and so at this point this function is undefined, and here you have f of x when you apply the limit. So here, from the point at x where the function is undefined, so to the left and to the right, this is delta, or you can say the change or the distance between the two values, and centered at the undefined point. And here you can say this is delta. For example, this is x naught. So this is the point x is approaching towards. So this point is going to be delta, or the distance, minus x naught, and this point is going to be delta plus x naught. And here as well we have this is e, or f of x plus e, and this is f of x minus e. So what this definition says, that if someone gives you e, or if someone gives you the limit, that if someone says that find me a change or the delta when he gives you this epsilon. Epsilon is basically the final answer of a function when you apply the limit. Or for example, he says that I just want to find the delta when the value of e is this close to the point where the function is undefined. So for this function, if you say that if you want to find the delta or the change when, for example, if I say that e equals 1, so when e equals 1, I want to find out that what is the change or what is the delta when e equals 1. So what you're going to do is let's first convert so let's first write this term as I wrote here. So you have absolute x is our x, and x minus x naught, the limit which it's approaching towards, minus x naught. And also this x naught or x minus x naught cannot be equal to 0, because you know, if it's equal to 0, then it means that it lies at x naught. But you know, if we are calculating this, we are making sure that it does not lie at this point, because at this point the function is not defined. So it should be greater than 0 and less than the total displacement, and that is delta or the change. So here our x naught is a 2, so we say that x minus 2 less than delta. And for e, I have 4x, or the function f of x, 4x into x minus 2 divided by x minus 2 should be less than e. So first, how are we going to solve this question? First, we are going to cancel out this x minus 2 terms only when we are considering the fact that the function at this point does not at x equals 2 does not exist. It only approaches to 2. So we write 4x absolute. No, it's going to be like this: 4x x minus 2 divided by x minus 2, and then you have minus L. So for example, its limit is the limit of this function is 2. For example, let's say at 2 it's or let's say 4. So you have minus 4 whole absolute is less than e. So you cancel this out, these out. You have 4x. You have 4x minus 4. You have 4x minus 4 whole absolute. Yes, whole absolute less than e. Here you take 4 common. So you have, or let's make it 8. So because I'm just giving as an example, because we want this whole expression to become this one. So you have 4, you take 4 common, so you have x minus 2. You get x minus 2 less than 3. And also 4 absolute is 4, so you have x minus 2. So you have x minus 2 is less than 3 by 4. So this is your e. So if a person tells you to that E equals 1, that he wants the unit that is 1, he wants one unit close to this limit, or close to the point where the function does not exist. He just wants to find he just wants you to find the delta, when E equals 1, or when he wants this unit 1 to be this close, to be 1 close to f of x, or the point where limit does not exist. So that E, so for E equals 1, your delta is going to be 3 by 4. For E equals 1, your delta is going to be 3 by 4. So this is how you know that when he asks you to count, or to when he gives you the value E equals 1, the change here, it's the x minus x naught, or x minus 2 is got to be less than 3 by 4th of E. 3 by 4 of E. So this is how you're going to find the value E, or the epsilon of this limit. So this was about calculus. Now let's discuss some things in fundamentals of computers. So today what we learned was memory cards, the storage devices. We were learning about storage devices, so we continued on towards memory cards. We learned express card modules. Then we learned iCloud storage, or just the cloud storage. We learned what are optical discs. These are all storage devices which you use to store your data inside. So you have memory cards. These are portable cards which you insert into mobile devices, or desktop or notebook computers to store your data inside. Express card modules are just like memory cards, but they are card shaped, and they are 3.5 millimeters thick, and 7 something millimeters wide, I think that's the measurement. And these are also used to express card modules are also used to increase the storage, or to read and write. You can read and write on these express card modules. You have cloud storage. So sometimes your computer cannot store that much data, because your hard disk is not capable of storing that much. So what you do is you subscribe to a cloud storage. The reason why we call it cloud, because you don't know where the server actually is. You just subscribe to it, and it stores your data. So here this is a server, and you are connected to it by the internet, and you store your data through, and you can communicate with this server from any computer or mobile device that is connected to internet. And when you subscribe to it, it first provides you with some free space, and after a little time period, it asks you for the fee. So that was cloud storage. And then we have optical discs, or optical discs, which are used, and there are different types of optical discs. There are read only, or write only, or read and write, and erase one. So if you have all three characteristic, then you have a good optical disc. Alright guys, thank you so much.